So, welcome to you all. I'm happy to see you. It's an honor to be here in China and to give you some information about Forcam. So, first of all, I think I have to excuse, I speak no Chinese, and most of you know German, so I will do it in English. My name is Michel, or in Chinese Mi Ben De. I'm the COO of Forcam, but now I'm responsible as the head of the company for consulting and finance and human resources. But I'm a technician, so I grew up with the project, so I hopefully can give you a lot of detailed information about the Forcam company, about what we are doing, and about the technical aspects too. I will show you the software in a live demo, and you can address all questions you have immediately to me, and my goal is to make it as interesting as possible so nobody has to fall asleep. This is so, typically if I am at a customer, first of all I'm talking about requirements. So this is the first I do if I go to potential customers, is to ask them for feedback. What are you looking for? In many cases we go through the plant to see the manufacturing of our customers. Then what I want to do, this I will skip today because yeah, you are not a potential customer. So then I will give you an overview about company, Forcam, about the thing we are doing, our vision, that's shop floor management. I come to the product, factory framework, a PowerPoint presentation of what our software, of the different modules and so on. And I give you a live demo of the system. I have the system running on my notebook, so I can give you a live demonstration of the system. So let's start with Forcam company. Forcam company is meaning what? In 3 points we can show our key mission. The first is that we are focused on a key competence in shop floor. The second is we are on the way to be as innovative as possible, to use the newest software technology that's available. So that's the second goal we have. And the third goal, the mission, is we want to support our customer to optimize their manufacturing. These are the 3 main missions we have at Forcam. So this will be clearer if I go ahead. So I want to tell you a story about what's the history of Forcam. So Forcam was founded in 2001 as a spin-off of SAP. I think you all know SAP, right? Yes. Okay, so SAP is a great ERP system, enterprise resource planning, to manage orders all over the company. I always make the picture, SAP is flying in the sky somewhere above the whole company and organizing the company. But the manufacturing in many companies is on earth. They have totally other problems. And there's a gap in between. And one of the first goals we had when we founded Forcam was to exactly close this gap in between SAP and the manufacturing world. It's I very often use the word, it's a black hole. There's a black hole in between, and our goal is to fill this black hole. It's the first thing when we founded SAP. A lot of SAP managers joined Forcam at this point. The second was, we had a clear vision that we don't want to make projects, but we want to have a product, a software product, a reliable product, and a very innovative product. So we started the development in 2001 on a web-based platform, pure Java, web-based, which is now, it's obvious, yes, everybody wants to have web-based, but those years ago it was a new thing. And from the start we decided to do it web-based. That's a big benefit right now, because the history showed that we were right with this. So if you want to create a product, it's no good idea to close the doors and to develop a software for some days, months, years, and then you come out telling the people, Chaka, this is my software, please use it. Doesn't work. So you need a customer, it should be customer oriented, and that's the reason why we decided we want to develop this product with a big customer, with Daimler. Mercedes-Benz was our development partner. And to be honest, we didn't earn a lot of money, but we learned a lot about the needs of the customer. And so we developed the solution. Soon with the development, they used our system at the most expensive machines that are in the car manufacturing. That's the press shops. One press, 6-step press, costs so much tremendous money. So you see, it's more than $2 billion. That's we are controlling with our software. So it's a huge investment, and that shows how they trust into our solution, and they get out a benefit of that. Up to right now, Daimler for sure is constantly our customer. Up to right now, we have 14,000 machines connected to our system. 14,000. And I think then it's obvious, if I go back to SAP, it's obvious why SAP isn't capable to manage with, to deal with data, process data from 14,000 machines. Would blow out. So this is the timeline. Because we were very successful with Daimler, so Audi has seen this. And Audi told us, yes, we want the same system, because they are successful, and we started, I think in 2006 was the first pilot at Audi, and within 1 year Audi raised the productivity, the availability of their press shops by 20%. And if you think about the investment in the press shops, this is a huge amount of money they get back, and ROI, the return of invest, is the key in manufacturing industry. They only want to spend money if they get a lot of money back. Yeah, and we get other plants. For example, at Audi now decided they will make the new plant in a city called Münster near Ingolstadt, a totally new plant where they produce their components. Every machine will be connected to Forcam system. Also, BMW choose Forcam in their press shops. We are in rollout phase for BMW, and the press shop in Shenyang uses our system too. For sure, we not only have the car manufacturers, we have some smaller, mid-sized companies. For example, MTU building turbines for aircrafts, or MSR has a plant in China too. They raised up the availability by 25% within a year. So tremendous rise of availability. They could realize. And maybe another customer, the Schaeffler Group, very interesting. So we had 2 meetings, one in the last week, one this week in the headquarters. We were in Suzhou and in Anting, and very interesting because it's a long year customer, Schaeffler. And we trained them in the first plant, it was in Germany. We trained them how to roll out, and they had their own MES team. Now the first rollouts they do totally for their own, so I even don't know in which country, in which plant our system is installed. We only get the information, another 100 licenses, and done. They do all for themselves. Okay, and that's an important strategy we have at Forcam that might be interesting for you. Forcam focuses on selling the software. For sure we have consultants. If a customer wants a service, we can do that, but this is not our main business. We don't want to sell services to our customers. So we are happy if you can do some services or the customer itself can do some services. This is what we prefer. Because we were innovation, for sure we needed partners. We got some awards because we have a very innovative software. So our software gets the award from the country, and our customers were 3 times. It's 2009. It's again in 2012. We were Factory of the Year. Our customers got an award Factory of the Year because they are very successful with innovative solutions. Okay, that's just to give you an impression. And one maybe important thing, because we are located we are a small company with about 100 employees. So for the big customers, this is less focused on pure software for shop floor. Yeah, this is a good size. But for the big companies, for an Audi, this is nothing. So it's important to have a safety within the company, and this safety is guaranteed by our shareholders. So Dietmar Hopp, the co-founder of SAP, he's a shareholder of Forcam, so this gives us financial independence. And I think we are one of the less companies, or maybe the only company, that's denied an offer to be bought by SAP, because we want to be independent. Yeah, that's the way we are. Okay, any questions to the history? Okay, then I'll go on. As I told, the headquarters located in Germany, in the south of Germany, at the Lake of Constance. We see the lake, and behind the lake we see the mountains of Switzerland. Really nice holiday area. We are located in England and in US, and we have teams wherever the customer wants us to have a team. In many countries, as I told, the customer doesn't need us because he for his own does the services. But if he needs, we can establish teams, and I'm very happy that we now start with a team in China. Maybe the next flag is Korea. I look in the internet for the flag of Korea and place Team Korea. Okay. This only shows, I didn't translate it to English, it's Chinese only. This means we are very innovative, means web-based, 100% web-based, means technology where we connect to the database, not sending SQL statements, but CPU-based, cache-based database mechanisms. That's what SAP calls HANA. So we already have in our product. We have multi-language, we have different time zones, and so on. This is where we are supported. We support cloud and so on. For us, this is standard. Overall, this is very innovative, and we are honored by some awards we get for this. Okay, so yeah, for sure we do some marketing. We have brochures and so on. If you request something, so ask us, and you will be provided with information. And we do conferences, because this is a very interesting thing to do, networking together. So we have an annual, for example, we have an annual congress in Germany where the head of manufacturers, the managers meet together. They have a meet together and they tell they hold speeches, they are telling about projects, the results, new developments, not only concerning Forcam, but concerning optimizing manufacturing. What is the newest thing? So they're exchanging information. We have customer days where the customers can meet and network together, and we have the possibility to visit existing customers. So our customers invite others interested to their location and tell about their projects, what went good, and on the other side, which are the risks, which are the challenges, and that's interesting for a lot of people. In 2011, we were invited for this conference from Audi. In 2012, we were at Daimler, and next week we will be at Porsche in Stuttgart at the Porsche headquarters to make exactly this conference. And I have a short video. I want to show you the video, a short summary of this conference. So, was at Daimler in Stuttgart, as I told, in the headquarters. This is a museum. There's a museum with the car history inside. So it was a nice location, and we had, for sure, we had Forcam brochure. Yeah, we had we have nice girls. Blonde ones. My assistant. Yeah, this is a customer telling about his project. It's from BorgWarner, Martin Strehl from BorgWarner. This is a Daimler guy telling about the new engine technology of Daimler. And this is a successful story, 4.3% in 6 months. This is BorgWarner in Germany. This is Planning Utility, is a company from Switzerland. They used our detailed scheduler. And yeah, this is Professor James Lee, Uni Cincinnati. We have a close partnership with the University of Cincinnati. Our headquarters is located in Cincinnati, exactly to have this partnership with the university. Online visualization from Forcam. And this is Franz Gruber, our CEO, my partner in chief management. So he's the CEO, I'm the COO. Okay, so let's go ahead. So it was a question of you yesterday evening. Which customers does Forcam have? Interesting thing. So I placed some of the customers, not all, but some, on this sheet. So first of all, you see our customers, as in the history, are car manufacturers. So the big car manufacturers, Daimler, BMW, Audi, Volkswagen, Porsche, Evo buses, Daimler Truck Group, building the big buses. Then the automotive suppliers, the suppliers of the automotive industry, and I think we have a lot of those big ones there. So we have the Schaeffler Group here in China, very many of plants too. We have Mann & Hummel, the filters and so on. We have Mahle, the Bosch Group, ZF, MSR, BorgWarner, First Alpine in the steel business. So a lot of automotive suppliers in the same business. But also a lot, you might see here, are the mid-sized companies, the machine builders. Schuler builds presses, big presses, SEW electrical engines, KUKA for the robots, the KUKA robots, for long years is our customer in different countries. Aalborg, plastics machine, and so on. So this helps us to understand interfacing the machines, which is an important thing, because at these customers above, we have to interface machines, and sometimes these are exactly the machines of our customers in this area. But not only we are focused on these branches, so we have some customers in aerospace and defense. So 2 weeks ago I was at Airbus Industry. They are very interested and they committed to make a pilot with us. So we are now at Airbus, at EADS, M2IL engines, and Astium and satellite technology. And defense, Rheinmetall, we talked about that yesterday too. So Rheinmetall is a customer of us too in MAN. And in totally different businesses. Our experience was they need, wherever they are manufacturing something, they need optimization so they can use tools like ours. Even in food industry, so it sounds a totally different thing, but I've seen the customer, so if you have a look on a line slicing meat and packing meat, so it's nearly close to any line producing mechanical parts. So it's the same automation technology, it's the same requirements. So our software is fitting for this too. So we have a lot of other things, healthy machines, or cooking or food industry. This main is a Netherlands company. They are preparing food. They are building machines to kill chickens. Interesting. Okay. So, what do we want? Our goal is not only to install a system at the customer, to sell a system to the customer, and if he installs, we are happy. No, no, no. Then our engagement starts because we want to have a successful customer, and that are the statements we are waiting for. This is Axel Bienhaus. He's responsible for all press plants at Audi, and he gave us this statement. So, due to factory framework, to our product, they could increase their productivity by 20%. And might be you can imagine how important it is and how difficult it is that a top manager officially gives you the acknowledgement to use the information that they increased by 20%. Because on the other side, this means they could at least, before they could at least have been at 80%. So I have very big respect from this manager, because he understood it doesn't help to say we are at 95%. He understood that it's important to be true and to see, yeah, we are at 50% or at 60%, and we have the chance to rise. And they did it by 20%. And for sure, not only with our tool, but they did a good job, a very good job in this continuous improvement project. They used the tool ideally. If you buy a hammer and simply the hammer is somewhere else, you don't use it, it doesn't help. So they really understand to use the tool. And that's what we want with every customer. Another, this sample you have seen before, MSR technologies, they increased by 25%. And I have a video too I want to show you here, because it explains a little bit, and I give you the information besides when the video is running. So why the watch? The watch is because they tell anyone who produces, who manufactures, should at every time know in which state his plant is. Transparency, real-time transparency, every minute, every second you should know the state of your company. This is typical manufacturing area. They have a lot of mechanical machines, drilling, milling, whatever, grinding machines, producing parts. Typical manufacturing, we found some of the parts. focus automotive supplier to building components, having a lot of lines, combined machines. And the challenge was with our software to give them transparency. This is a worker, female worker, and you see wireless, so they connected the machine wireless and the terminals, the user terminals wireless. This is a typical Forcam user terminal. So the worker is using the HMI of Forcam. This is the responsible person for the manufacturing, the head of manufacturing. So this is his office. In the back of his office he has a big monitor with a screen, and on his PC he simply starts the Internet Explorer and he sees maybe there's something going wrong, and now he has a look and he sees, oh, there's a red one, something happened to this cell there. The others are running well, but this cell has a problem. Now he's analyzing what's behind this problem. And he's cooperative. He doesn't go out and telling the boys, hey boys, what's going wrong? Hey, he's asking them, oh, I've seen it's red, please explain what happened. And so he went to the place where the problem occurred and joined the worker there at the location and asked them, what's the reason why the machine is stopping? It's a CNC machine, and you've seen that constantly he had a problem. He didn't fulfill the plans. It wasn't a single stoppage, but constantly he didn't fulfill the plan. So he goes to the worker outside and he identified the problem. It wasn't a machine problem, it simply was a problem that he didn't have enough boxes. So the worker did stop the machine because he hadn't enough boxes to put the parts inside. So a very small reason behind, easy to solve. They bought some more boxes and put the boxes to the machine, and the machine could run at full speed. It only shows this is a sample. Sometimes the problem is very small, but the effect is tremendous. A machine with a lot of costs isn't running at full speed because some boxes are missing or material is missing or whatever. Yeah. So, and this video isn't paid by Forcam. That's an interesting thing. The customer itself paid to have that video. So he's so happy with the customer is so happy with our system. So he told us he wants to have this video. This is the CEO of MSR company. And he tells it wasn't only 25%. This is 5 years ago. They had the 25%. They had another campaign this year where the focus wasn't to avoid stoppages, but the focus was to shut down the machines if capacity isn't needed. So they had an analysis, which are my bottleneck machines. They built buffers and they could shut down. The bottleneck machine runs 24 hours, but the other machines, they work to buffers and skip a shift. So it would save another 10% costs by simply exact planning and shutting down, skipping shifts. Oh, that's interesting. Yeah, so nice robot, no Kuga robot. Okay. So they are telling, and the key was to know all the time to have a direct transparency in the plant. This was the key. That's what they are telling. Okay. MSR technology and Forcam. Good. Let's go ahead. Just a statement from Bob Warner. He's the head of manufacturing at Bob Warner in Markov. So, if I'm asked which 3 projects I would recommend, or which are the very important, so I would figure out those 3. The Daimler with the 14,000 machines, for sure is an impressive size, maybe the biggest installation, I don't know if there's a bigger MES installation worldwide. I don't know any other. So maybe the connectivity is one of the key things, and then MTU might be a good thing. They only in brackets have 400 machines, but they have 25 different PLCs, so the variety is very big. So this is a challenge very often too, to connect to the machine. And maybe looking at the SAP integration, so I think the Scheffler group has the most, the best and deepest SAP integration right now. Okay, this concerning information to the company and what we want and what is our goals, the targets. In what we typically add in our presentations is shop floor management, because in some mid-sized company this is very poor, and even in the big companies they have addressed shop floor management, but most of them are not living it or doing it without a system. What's behind the shop floor management? Shop floor management means, this is a word from Lord Kelvin, a very old guy, and he already told, if you cannot measure something, you can't improve. It's like if you are not know where am I and you want to go somewhere, so if you start, you go to the wrong direction. If you want to go somewhere, you should have a goal and you should know where am I right now, and then you can make the right steps towards your target. That's what's necessary. And how do we do in case of optimization of manufacturing? This means, first of all, we have to have transparency. We need transparency, the information about the actual state of manufacturing. If we don't know that, any action we take might be good or might be wrong. Then we have to have a continuous improvement process. Some in English they call it PDCA, Plan, Do, Check, Act. So this continuous improvement, and that's what I meant. Without a continuous improvement using our tool, so the tool doesn't make the results. Yeah? And to get this continuous improvement running and stop discussions within a company, you need reliable performance measurements and metrics. You need facts, hard facts, to define the problems and to define the actions to solve the problems. Otherwise, a lot of manufacturing companies not having these systems, they have a lot of discussions. The production guys tells, oh, the machine was broken and I waited 3 hours for a maintenance guy. And the maintenance guy, he tells the manager, that isn't true. He called and I was 3 minutes later, I was at the machine, but I had a hard job. I had 3 hours to fix the problem at the machine. And the machine builder tells the manager, no, can't be, our machine doesn't have stoppages. Please look in my log. My machine only stands 10 minutes. Now, how should a manager, with this information, solve this problem? No chance. So he needs true, reliable data. What was the stoppage of the machine? How long how long was the time for maintenance, and so on and so on. With this picture I explain to many customers the situation. I'm telling them this is a very old, bad company. So 50 years ago, a very traditional company. The management has no CIP, they don't meet daily. They have writing on paper. If they have delayed information from IT in Excel or on a paper, they do management by remote control. So if a machine is broken, the worker maybe half an hour he detects, oh, machine is broken, then he writes down at the end of a shift, he writes down 3 hours machine broken. There are some typers, female typers, typing into Excel, and 1, 2, 3 days after, the manager may have the information, oh, yesterday was a bad day. This is crazy, because if I know now that yesterday was bad, I already lost a day or 2. And the workers outside can't remember what's 1, 2, 3 days ago. If you ask me 3 days ago, well, what did you do? How much time you spent driving? Oh, I have to think, and I'm not sure. Maybe 2 hours, 3 hours, don't know exactly. That's exactly the world. And if I explain to customers, and then I'm telling, I'm sure you are not working like this. And in many cases, the customers say, oh, we are sorry, but exactly that's how we are right now. So, and I'm telling them, forget this, you should be there. This is the way you should be. Means you should use newest technology. You should have a shop floor management system. If the machine is broken, 1 second later, he should see in his office switching from green to red. There should be a big board hanging in the manufacturing area where at the coffee machine, that's ideal, having a big screen at the coffee machine where the workers stand and discuss, and there they should see, oh, red, oh, let's stop drinking coffee, let's go to the machine. Yeah, that's it. And that's the reason why Forcam offers this for free. So there's no license for those terminals, we only license the machines. So we are happy if a customer places as much information as possible. And who is the most important to have this information? That's very often a question I address to the customer. What do you think? What's the most? Who is the person who should have the most information because he has the most influence? That's not the manager. Sorry, he's an important person, but the most important is the worker itself. So he himself should have first the information. He should see the red color and the information, how good, how bad is the shift. It's him. So he should have it. And another thing, I always, when I do a presentation, I always invite the management, because another key factor is the management. Even if you install such a system, it only helps if the management forces to have this continuous improvement. If it's a hard management, if there's a boss sitting behind the table and something is reporting to him a problem, so the worker comes and telling, oh boss, the machine was broken half of the day, and if the boss makes like this, hey you crazy guy, shut up, and I don't want to hear these bad things, this doesn't work. He doesn't want to see the reality, so it should be cooperative. The boss should tell him, okay, 50% could be better, but explain why. So the management should train their workers to look on the data and to work on this improvement. And this takes time. If there's a management that forces the people to only produce, they won't have time to improve, and then there will be a limit of efficiency, and they can't go over this limit. Okay, so old world, new world, and as I told, a lot of customers are telling me, this slide exactly explains the situation. Still up to right now, we have a lean manager, yes, but still the situation is like this. And that's because lean management is good. If you make lean management by paper, this is good. If you have one machine or two, but not if you have 50 machines and 100 machines. Doesn't make sense with red and green and blue cards. You get crazy with paper. Okay. This slide explains the basic round trip using Forcam system. Typically we have a SAP system with the orders inside. So we download all the information that's relevant concerning orders, operations and so on. We show it in a so-called worker client, that's the window in the background. It means an ergonomic interface for the workers. So they can select machines and orders, they get some information from SAP, but they also get information from the real-time management. For example, if they start setup, they have the information how much time is left to the planned setup time, how much time is lost right now, or produced number of pieces or stoppages and so on. So a worker client to give information to the worker. So means shop floor information, ergonomical interface. Next thing is we connect to machinery. What's possible, typically we get out the signals for machine is in stopping or is running. Maybe we can detect setup, number of pieces. Maybe there are some machines, they are capable to read out error numbers, problem number, the reason. But in most cases, this doesn't help. In most cases, we need the worker to specify what's the reason behind. Not this error code coming from the machine, in most cases, doesn't describe the true reason of the problem. So we need the worker. And with both information, we can do a reporting diagrams like this. And in this diagram, you see a timeline, maybe a day, maybe a shift, whatever, a week. You see a number of pieces, and the black line is the planned target output. So this should be the output over the time. And as we have the shift definition, we can detect breaks. So this is the morning break they have. And then going on. And you see, here it was really good. A small problem. Green means production, red means stoppage. Small stoppage, but was quite good. Then constantly he didn't fulfill the plan. There was a break and the real problem started here. So blue means setup, so they changed to another material, to another order. If you look exactly, you might see the ramp is a little bit different to here. This is because this order has another cycle time than this order. And you see blue, the setup, and then the problems began. And they didn't have an output of parts. So this is the actual throughput. You can see the actual performance, and this is the opportunity for improvement. And might be you see the wording. I don't say these are the losses. For sure these are losses, but a loss is something positive. A loss is the chance to become better. So this is an opportunity. So it's the same with an optimistic and a pessimistic guy. If you ask the pessimist, what's about this bottle? So he tells you, the pessimist tells you, oh, already half it's empty. But the optimistic guy tells you, oh, I have more than a half available. So, and you have, this is exactly what you should think. So, if you have a efficiency of, in this case, and these are true values, and these are good values, by the way, fully automated line and so on, we are at 65%. But this isn't a bad thing, this is a good thing. If I'm at 65%, I have another 35 to win. I can earn money. Okay, so this means transparency, and with transparency you can rise to the maximum potential. And that's the goal. The goal is to be at 100%. Okay, so shop floor management. Who is concerned with shop floor management? Is it only the worker at the machine? No, it's the worker at the machine. The planner is very important. The engineer, the maintenance, the foreman, for sure the plant manager. So, but these are different persons. They have different roles. They want to have different information in different manner. That means Forcam system defines roles, and depending to your role, you get a view to the system. So we have the possibility to configure different views for the different persons using our system. So if a planner logins to the system, he sees totally different screens than a plant manager, because a planner wants to have interactively complex graphics to see all his orders on one page. The plant manager wants to make no click. He wants the system, if he logs in, automatically pop up with his dashboard and nothing more. And exactly that's we are doing. So we can have automated setup. So if the top manager logs on to our system, we can directly load his one and only dashboard and not more. So once again, the key is plan, do, check, act. What does it mean? It's the wording is from these lean managers. So it means if you today you are here at an actual state, red, not the best one, and you want to be here, a target state, the green one. That's what you want to be. So you have to install a daily plan, do, check, act mechanism. Means you daily and for example OD every day meets 9 o'clock for 15 minutes, and then they talk about the problems. How much productive time, what was the availability of the machine, good, or did we have bad availability, and if bad, why not, what was the reason, and then finding out the reason, they start a plan, do, check, act mechanism. What does it mean? It means that in the moment we identify, you may remember the video, if we identify less boxes is the problem. So we plan an action to ensure we make a responsible person, Mr. Whatever is responsible to ensure that at this workplace every time there are enough boxes. That's the plan. Then we for sure we have to check to do this, so he has to do. And for sure if you make activities and define a responsible person, you know what happens typically in work. There are other tasks and it's not done. So very important to check. Check again and again, are there enough boxes there or not? Maybe the first week this is wonderful, maybe the week after, again the same problem occurs, and that means check and act. Act means be careful, do it continuously, ongoing, check every week, because otherwise you may have the following over the time. You see, I'm producing and then I have a problem. At this point, you are defining an action to solve the problem. Yes, you act and then it goes up like this. And if you don't check any longer the next week, it's easy to tell you what happens. It goes like this. Yeah. So you have to check here to hold this line, check here to hold this line, check here. So constantly checking. And this you can't do manually. For this checking you need a system. That's plan, do, check, act. And this kata, I don't know if you're familiar, with this kata, this is the newest hype of those lean managers. They are telling kata, this is this kung fu fighting, that you learn to fight against these problems without thinking about. So it's if you attack a kung fu fighter, he automatically takes the right arm or the left arm, not thinking about, oh, should I use the right arm or is it better or the feet? So, and that's what the newest lean managers tell. Yeah, you should have kata. You should well trained to be prepared for the next problem. And yeah, this is how companies rise up by 20% or more. The Forcam modules. As I told, Forcam was from the scratch developed to fill in the gap in between ERP system, typically SAP, and shop floor. For sure, we have some third-party products we supply. Sometimes we have a document management, we have an interface. Sometimes we have a tool data management, we have an interface, and we have an interface to quality systems. QDAS. Sure. No, we openly, I didn't fix this. We, in every presentations, I do like this, so we included QDAS in our partner model.
Standard in the
presentation. It's I'm telling them, if you want statistical quality things, so QDAS is one of the best partners we have. Okay, but now let's focus on the Forcam side. So these are the modules. Modules means Forcam delivers one software to a customer. And one in big letters means we don't deliver single modules, but we deliver the complete functionality, but we hide the functionality. So modules are only enabled or disabled as the customer needs or not. This makes it easy if he wants additional modules to use, so it's simply a configuration and then he might use. And one software also means we don't have different versions for different customers. We avoid having individual software versions at different customers, because this is a bad thing. Because if you split your software individual to each customer and you make a major change in a function, so you have to do it once, twice, many times. So that's the reason why we avoid having individual functionality for each customer. For sure, each customer needs separate functionality, but we do it by configuration. So we configure this Audi using this function, and then might be Audi is the only one and Daimler uses a different function, but within the software both functionalities are inside. It's only hidden for the one or for the other. And this ensures we have one major maintained version line in a good quality. We had a time where they differed because Daimler forced us to do other things than Audi. And we spent a lot of time and money to put this together again to ensure the quality and the pricings, because there's a big benefit if we now develop a functionality for BMW, so directly Audi and Daimler might use it if it's interesting for them. Okay, so short side comment concerning one version. So these are the different modules. So for sure we need a module to interface to SAP, but it's more than an interface. It's a known module, it's a piece of code running in SAP, it's coded in ABAP, it's many years development, including business logic to integrate to SAP, because I told you, remember, one of the key figures of Forcam is perfect integration into SAP. This is done by this. to exchange data. Simply we synchronize the orders, but we add a lot of real-time information to the orders here from this side. So typically the rough planning of orders, the creation of orders is done in SAP, then they are downloaded, and if an order is started, the number of pieces, the setup, start of setup time, all this information is done by our order data management. And you might see the green color background. So these are the plus function. These are from our prospect the most important functions to rise this productivity. So you need order management and you need machine data to connect to machinery to have exact timestamps of your stoppages and so on. And then you can have performance analysis, online visualization, and alerting, automatic alerting of the system. I will go into more detail. I have separate slides for each of the modules. Other modules to optimize are detailed planning and control, because many often the sequence of the orders makes the first difference. If you choose the right sequence of orders, so you save setup times or something like this, or you can organize material better, you can avoid big buffers and so on. So detailed planning and controlling is one of the things. Then production data, this means avoiding too much paper in the manufacturing, having all in electronic objects and offering to the customer. Then we have process data. This means not only having states from the machine running, stopping, error number, but also temperature, pressure, forces and so on, and to track and trace those data, to have a serial ID, so the customer might analyze the history, what were the circumstances under which my product was manufactured. And the last module, personal data, means clock on and clock off of persons to the system, so you can having the information for your order, not only the time an order needed the machine, but also how much workload, how much person hours are combined with my order. That's interesting for the finance guys, and this information, the compromised information, we are capable to send back to SAP. And that's very interesting for the commercial, for the finance guys, that they have a real-time feedback how much time is actually consumed for a special order. And sounds very easy, but up to right now, most companies I know, before they installed our system, they had no real-time information how much time compute. So the finance guys are working with the planned times. So they define a time, this order is planned with 10 hours, and for finance they use 10 hours to calculate the costs. But yeah, with our system they have the true feedback. Might be it's a good planning, then they only need 8 hours so they can earn some money. But in many cases they plan with 10 but need 20. So yeah, this makes a problem, and they offer too cheap prices. So interesting for the finance guys too. Okay, so let's go into more detail. How to connect machines. Such a project, we can differ in 4 steps. Step 1 is to connect to the machines. Physically connection to machines, getting out the signals. Step 2 is standardizing, normalization, because every machine is a little bit different, and maybe a state production machine is running might be totally different from machine to machine. Maybe at this machine the door has to be closed and automatic switched on. Maybe at this machine there a robot has to run or something else. This means standardization, because on the above level you want to have the visualization and your KPIs like overall equipment efficiency, the efficiency of your plant. You don't want only to have the efficiency of each individual machine, but you want to have to summarize and have one efficiency for a couple of workplaces. And that means you have to standardize first. Then you have the visualization and the reports. And the step 4 is to plan, to compare planned versus target value against true value. And then that's this continuous improvement. These are the 4 major steps. And I now go into more detail. So step 1, how to interface machines. This is for the technical guys. So we have different machinery. For sure we have manual workplaces too, but now we are talking about machinery. So how to interface machinery? It's behind is not to interface the machine itself. In most cases it's interfacing the PLC that runs the machine, that runs the access. So we have a variety of different PLC. In US we often have Allen Bradley. In Germany we have a lot of Siemens. We have Japanese like the Matsaks or Fanucs or whatever. So different PLCs we have. To synchronize with all these PLC, we have so-called plugins, software plugins in our software. These is an extract of the plugins Forcam offers. And for sure, if you have a Fanuc control, you have to have the Fanuc Focus software protocol to talk to each other. That's the first step. Sometimes this works very easy. Simply S7 having a network interface, so you only need to cable the PLC to start the corresponding protocol and all is running well. But in most cases this isn't that easy because, for example, the PLC only has a serial interface, no networking interface, so you need a piece of hardware to adapt from serial interface to LAN interface, for example. We offer such cables. Yeah?
Okay, one question about the machine, because you want to lead to a different brand of machine.
Yeah.
And is there any PLC work to do from the customer side by themselves to set up the interface to link to your adapter or plug-in board?
Yes, exactly. There is the responsibility. So we from Forcam see responsibility up to this lane, and the responsibility of the customer is maybe we can give him consulting, we can give him information, but the doing is customer side. Because we are not the electric trained, well-trained people, so the customer itself should do this. And this sometimes is a problem. For unexperienced customers, this is a challenge.
Yes.
So we can recommend, we can tell them, okay, for Fanuc, for example, we know it's easy to connect, but only to some versions. So what the customer has to do is to give us exactly the version number on the plate of the machine. Then we can send an email to Fanuc, and they will tell us, is this version at customer X capable to run that Focus protocol or not? It differs from machine to machine. In case of Siemens, it's the same. Maybe it's a S7, then it depends, is it a coprocessor card or not, and then it differs which protocol is running on the PLC side. Maybe if they want to get detailed data out of the S7, it couldn't be done by calling. Maybe they need MC's RPC protocol. So the customer has to contact his supplier and ask him, is the MC's protocol installed?
But they don't need to change their PLC. It's not about they do anything programming on the PLC side.
No.
It's just about we need to know where to find the signals, how to connect to it.
Yeah.
So the customer don't need to change his PLC.
Yeah.
He just should tell us where to find the data we should get in the PLC.
Yeah.
It's really, I think you thought about they need to program something.
Yeah, normally you look for some small programming in PLC side and set up the talking with up-level system.
There's some configuration might be needed to enable this protocol, but not programming on PLC side.
Will be not programmed.
Because they have different modules.
Yeah.
They have different modules.
Right.
Module maybe for these two machines and
So-
another module for the others.
Yeah.
So how you connect it? You connect with different modules.
So let's make
You know,
let's make a concrete example there.
它就是一个查询。
I have it on the next slide, but I think it's a good
원칙적
idea.
프로토콜 맞추는 거는
我们有的时候在比如说看 PLC 里面这个东西
커스터머
盖
집에
的这么有可能。
무조건
So
이쪽으로 맞춰줘야
I think I have separate slides to this, but I think it's a good idea to make a simple example at this point, because we have a lot of variety. But let's make one sample. There is a machine, and within the machine, so means this should be the machine, the mechanical part, and there's a 7 connected to the machine doing the X movement and so on. Yeah. And then it's the question how to interface with LAN, because the first step is every time to connect the machine to LAN protocol. Within the S7 already the machine supplier installed a piece of software moving the access and so on, and for sure they have a data structure structured in data blocks with words and bytes and bits, so they have a predefined data structure running on that. So, and now Forcam is coming, our server above, and there's a so-called data acquisition unit with a plugin for S7 activated, and then we are connecting. But even if we are now at this point, it's a 7, there are multiple protocols we can use. One of the protocols is the one that the HMI, the programmer of S7 typically use. So this is capable to do polling, means we are capable to every 100 milliseconds have a look in this data structure. Polling and looking and looking and looking. And then the only thing we have to know is at which position in the data structure is the signal that we are interested in. For example, if we need a signal machine stoppage PLC error, so we need the customer or the machine supplier to tell us PLC problem means database 17 bit number 6. This bit is PLC fault, for example. So we need somebody telling us where in the PLC of the machine, at which location do I find the right signal. So he don't have to change the program itself, but he needs a documentation, or to ask the machine supplier, please tell me where do I find this information. This runs very well, so it's easy to use, no change. Sometimes, for sure, this isn't the most, because you go bitwise, this is not the ideal method to get out a large amount of data. That means some customers think about preparing a special data block, so we can read out a complete block of data. We can read out 10 bytes, and then it's much easier. So because if they have other machines, they predefine, for example, an OD doesn't accept that the information in every machine is found at a separate place. If OD orders a machine, they predefine, I want my MES data block in every machine the same. This easifies the handling, so it's easier. But this means the supplier of the machine has to copy data somewhere in this block. And this, at this point, yes, this the machine supplier should change or add a small part to his PLC program copying to a data block. Sometimes the customer wants this, sometimes it's simply reading the data. And why it's in the standard is to not influence this, because most of the machine suppliers are telling their customers, if you change anything here, you will lose warranty.
Yes, that's
Yeah.
right.
That's exactly the point, and nobody wants to lose warranty. So typically, our customers are happy if are telling it's only reading without influence to the machine. Okay, but sometimes there's another thing. Sometimes because of these warranty things, the customers do for their own. They place a separate line PLC. So they place a separate S7 where they connect to the field buses of the machines, and on this the customer itself can place a PLC software. He hasn't a problem with warranty, and this is connected to the system. This is the next way how we can interface. It's widely used because then it's a separate PLC, it's a PLC2. They can connect to the field bus or to the PLCs, but they don't lose warranty if they place some. Because this is the work right now, so yes, you need different plugins for different machines, and yes, the customer itself has a task, and sometimes it's hard to explain because the customers are telling us, yeah, you should have connected already 100 Siemens. You showed me 14,000 machines, for sure there are some Siemens. Then I have to explain, yes, that's right, but your machine is individually, because your machine supplier programmed something that's only running at your location on this machine, so please contact him and ask him for documentation, where do we find the signals and so on. So it's not a big job, but yeah, we can't avoid this. And what happens if there's a PLC inside that or no PLC inside? It's done by relays or by a PLC without a connection. So in this case, we offer a so-called I/O box. You see here. It's a small PLC we offer where you can, with a LAN interface and a small program from Forcam running on that, with I/O cards, so a very cheap system where you can cabling direct out of the cabinet. 24-volt signals can be directly connected. This means it's a very easy and still the cheapest way to connect, but for sure, because it's digital I/O value, it only supports having digital information, running, stopping, counting pieces, but not error number, error text, transferring text characters and so on. But this is an easy to install utility without having to connect the PLC. Sometimes this is the best way to connect machines very easily. Okay?
Yeah, okay.
Okay, so now the slides, we talked a lot, and now the corresponding slides to that. So what does it mean, standardization? That means you have some signals out of the PLC, and this might probably not be the signal machine is running or machine is stopping. Might be, in many cases, this is program is running, a door is closed, speed is at X% or something like that. That means you have raw signals out of the PLC, and there has to be a logic inside Forcam to combine this information. And here you see a definition of what is state production for different companies. And in many cases it's not different for the companies, but also for workplace to workplace. You might define production, that means green color is when automatic is switched on, program is running, override is not zero, and cycle is started, or any combination. Yeah, that's what I mean with standardization. So in your visualization and reports, you only want to see running or stoppage, green, red, not the signals behind. That might be different from machine to machine. So the steps again. First, connect, it's Chinese again, I have a mixture. So connect to the machine. Most cases the PLC, so get out the information where in the data structure are the relevant information. So means at input data block is the temperature, data block 14 is an error, and so on. So identifying where in the PLC are my signals, then integrating the signals, defining automatic or error is if signal 1 and 2 or and so on. So it's a little a programming language, an easy programming language to combine those signals we have included in our data acquisition unit. Number three means to combine all this information from the machine, start-stop information, red-green, combined with the user's information, starting an order, selecting an order, giving a stoppage reading, and that in a timeline added by additional information like another worker is logging on to the system or any other information, and then we have a timeline. And typically a timeline, if we talk about a day in Forcam is not 0 to 0, not midnight to midnight. Typically we are totally thinking in shifts. A day is early shift, late shift, night shift together, so typically from 6 to 6 or something like that. That's very important because a lot of other software vendors, they are thinking about a day and so on. So we are completely based on shifts. That's very important for the customers because they have the same understanding, but it's configurable in the Forcam system. So at Forcam we have a very detailed view into the timeline at the machinery and the orders. So at Forcam we see the event when setup is started, and we see the single stoppages, a lot of stoppages. So we can summarize this information and give the summarized information per upload to SAP. For sure it doesn't make sense because, for example, SAP doesn't support an event setup started. So SAP only deals with duration. Setup took 1 hour. So and that's the reason why we don't send every event to SAP, especially not the short time stoppages, but we compress information, we summarize information, and maybe at the end of the order or at the end of the shift or every hour we upload this information to the SAP system to ensure that they have real-time data too. This module is auto data management, as I told, easy to use worker client and a so-called office client. Web interface, you only need a browser with mouse and sophisticated HMI. We will see later on that. Okay. So we have a built-in visualization having different colors or numbers with a drill down, so you may zoom into groups of machines or select different reports from that to look in the history, so with hyperlinks and so on. And we offer a free editor, so you as maybe the interface to the customer or the customer itself might change the visualization or create new layouts for himself. So it's an integrated, easy to use editor to create such screens we see here. And the visualization means the actual state of the machine. Forcam system includes a lot of predefined reports, around about 100 reports. And a report doesn't mean a fixed printout, but every report has parameters where you can select, I want to see this for machine X, and I want to see a day or a week or a year and so on. So you have some parameters and then you have reports. And it's not a good idea for a customer to have to use 100 reports, because then he might not lift the system. So he should better use 1 or 2 or 3 reports, not more, and use this continuously, day for day. And these are 3 sample reports. For example, this report we have seen before ideally shows for mass production the planned value and shows the number of pieces and shows the states. So you can easily see where the problem starts, and to come back to the presentation of Forcam, you shouldn't recognize at the end of the day by writing the data that you have this gap. So what we want to happen is that the worker exactly here sees, oh, a problem is rising, and then he can do something against this problem, avoiding the problem. That's the idea. That's a bar diagram, simply a sample where every line means a machine or a workplace. So you can easily compare similar workplaces to each other. Why this workplace has a lot of stoppages, this not. Must be something happened at this. For sure you can zoom in the timeline and so on. Another good idea to use this report is within lines, if you analyze lines, a combination of machines. So you can see here there's a stoppage, and that stoppage is going through the line. If the first machine has a problem, then the second machine might have no parts after a while and so on. So this is a good report to analyze problems within a line too. Where's my bottleneck machine and so on. And this is a good report for a compressed key performance index, and widely used is the KPI, key performance index. Widely used is index, the so-called OEE. I don't know if you are familiar with OEE, overall equipment efficiency. This means the productivity of a machine or a whole plant is called OEE, overall equipment efficiency, and it consists of 3 factors. Factor 1 multiplied with factor 2 multiplied with factor 3. This gives the information, what's the efficiency of my plant. What are the 3 factors? The 3 factors are those 3 columns. Light green, darker green, light red, and that's the OEE, the last bar. So what is the first? The first is the availability of the machine. That means how much time productive is the machine. So if I have 24 hours, so from 24 hours the machine is productive, for example, 12 hours. This means I have a availability of my machine of 50%. So it means the time the machine is running divided by the total time. Yeah? The second, this is availability. The availability of the machinery. The second is the performance. Because if a machine is running, I'm not happy with this, because the machine should produce parts and should produce as much parts as possible. So the second means how much parts per time, the so-called cycle time, cycles to planned cycles. That means if I plan to have 100 parts an hour and I produce only 50 parts an hour, so this is half performance. Yeah? Even if the machine is running, I have a loss because the machine is not running at full speed. This is the speed of the machine. And this, for example, if I plan to produce 100 an hour and it's only 50 pieces an hour, so it's another 50%. And the last is the quality. I'm not happy if the machine is running at full speed and the result is scrap at the end of the machine. So I want to have good parts. So the last factor is good parts divided by all parts. And if we have 10% scrap, so this might be a 90%. And what's the result? In this sample, it's 50% multiplied with 50% is 25%, multiplied with 90% gives 20.5% this sample. This is a very important key performance index a lot of companies use, because this gives you in one information different detailed information is summarized. That's this. Okay, but still some work, because now if you want to analyze, you have to go into this report and this and this. For a manager, this is too much work. That doesn't like. Now I have to open this and have to open this. So Forcam offers so-called cockpits or dashboards. It means the combination of reports and visualization. So you have an own editor there too, so the customer can create his own dashboards or cockpits, and he can place information as he wants on one sheet. That's the best method, to place it on one sheet, so only one info to call, and looks different at every customer. The one likes the days, the other likes to see Monday, Tuesday, whatever. The third one likes to see my problems in a bar graph or chai graph. The other likes to have his top 5 problems, whatever. So could be freely defined which layout. And this is a nice sample for a cockpit. It's an Austrian company. They not only show the duration of a stoppage in hours, they show the money. So they show the worker a money stoppage, an hour stoppage at a machine costs money. So they directly show the money. So to make the worker more sensible. Now next step is, yes, I have a cockpit and there's easy files on one sheet, but the next step to easy file is, please system, please Forcam, automatically send this information every day at 8 o'clock. I want to have it on my iPhone. And exactly this we are doing. We are defining predefined tasks, we are defining triggers and actions. So the trigger could be every morning at 8 o'clock, and the action could be send this cockpit as a PDF to my iPhone, or could be print out these 3 reports we have seen in the printer of the meeting room. For example, we have customers, if the head of production or the foreman comes to the company, he doesn't go to his office first. In the morning at 8 o'clock he has the morning meeting, so he directly goes to the meeting room, and he knows that Forcam automatically has printed out his information, his reports on paper, and he takes these papers, goes to the meeting room, places it, and discusses with his workers, why is this and this and this. So this makes it easier for the customer to use all the stuff. For sure they can do a lot of more. These are simply SQL statements to the database. Means every information we have in our database might be used. For example, send an SMS if setup time exceeds 150%. Or planners sometimes they design a new tool and they define, send me an email if my new tool is used first in the production. So he knows now I have to be careful because my new design tool will today be used in production right now or whatever. Now SAP. I started foundation of company filling this gap in between SAP and shop floor. Nevertheless, SAP wants to sell something, so there are some SAP consultants telling their customers, yes, you might use SAP to connect your shop floor. Theoretically, it's possible, but SAP or any enterprise resource planning has foundation, has basic things like being transactional, having bookings with rollback, asynchronous processes, nightly runs, and so on. So they are the target is to have a stability in the platform. Changes are very complex. Mass data are not supported, and so on. So SAP is designed to ideally fulfill these requirements. There they have 100%, nearly 100%. But if you have a look on the shop floor needs, manufacturing area, you need real time. You don't want to have only have a duration of setup. Setup took 3 hours. No, you want to know setup is started right now. Means you want real-time events and you want detailed and mass data. You're not happy with simply having 10 machines connected and the 11th has a performance problem, blows out your system. No, you want to connect all your machines and you might have a lot of detailed stoppages because in many times those typical stoppages of 5 to 10 seconds might be a big loss. Not possible in SAP. Means the more you go into shop floor world, the poorer SAP is. Not because they can't do it, because they have not the good developers. It's because the basic requirements to the system. And that was the reason why Forcam does it the other way around. So we are focused on having the shop floor functionality and features. For sure, we become poorer in the enterprise level. We don't want to deliver functions that are already done in SAP. So we want to avoid this overlapping. So ideal for the customer is if he uses both. If he uses enterprise system where it makes sense for the high level, financial level, and so on, enterprise resource planning, and if he uses Forcam for the shop floor, then they have the 100%. And to ensure that this runs well, we have add-on and we certify it by SAP. Annually we send our code to SAP and they check, did Forcam do a good job? Development is ensured that it will be supported by following versions. So they are planning years in front of a new versions. We check. We have checked by SAP that our code will run in future versions. And this ensures that all runs well. And I have a small sample that shows that it's not, you are not done having a simple interface to SAP. A lot of software vendors, MES, so-called MES systems, they tell, yes, we have an interface to SAP, but they simply exchange data. And now I exchange, no, this is not enough. You have to have a lot of business logic inside. For example, if a worker books some pieces, and he wants to book 10 pieces. So he tells the system, I produced plus 10 pieces, but he made a mistake and added a separate value, so he booked 100. So okay, immediately after he did that, so he recognized, okay, I made a mistake, and now he has to do a correction. So he goes to his foreman, and what he wants to do is a minus 90. So 10 are only left, and for sure he does this in the MES system, goes in there, types in minus 90, 10 was the correct value. So what has to happen is now all the reports already done have to be changed, because the reports are done with those 100, now we have to change the reports again. That's what we do internally, but we also have to correct the value. But if the 100 already is sent to SAP, and SAP can't do a minus. SAP is an ERP system, no minus is possible. There the correct way to do is you should know the booking number of this plus 100, might be 1, 2, 3, 4, whatever, and then you have to roll back this booking of 100 and to have a new booking of plus 10. This is the only way to deal in SAP. So a lot of business logic is necessary to ensure the data are synchronized correctly, and this would be the worst thing if data are different in ERP and MES world, because then the acceptance is away. Okay, I've talked about a module named process data. Process data means, as I told, not only digital values, running, stopping, error code, but for example, and this is a sample from Audi, storing the measuring for the forces they screw the brakes. For example, they're producing axes with the brakes one side, and they are measuring the torques and forces, and they want us to have these measurements to compare to good or bad, red and green. So I think this is for a CAQ, this is standard 2. They want to combine with a serial number. So they are capable, and they want, at the end of the story, they want to have such a piece, for example, a complex turbolader. They take a turbo of a car, they want to scan, and they want to know this turbo is built of what components, which lots are used to produce this turbolader. They want to know this turbolader was drilled on which machine, at which time, by which worker, which were the forces are used to see if there's a problem. They want to see under which conditions this part was produced. This is tracking and traceability. And the first to start this is the automotive industry. They do it for themselves, and now they are asking all their suppliers. They are forcing the suppliers to do exactly the same. They are shifting the responsibility to their supplier. They are telling, if you want to supply me with components, so you have to have the data. If I have a problem in 4 weeks, so I want to have the data under which conditions this part is produced. So this is called traceability. Okay. One of the data that's used for in Germany is, for example, energy consumption, because we have a hype in Europe to reduce the amount of energy necessary to produce car. So this could be the energy consumption, for example, of a machine. Persons data, as I told, this means clocking on and clocking off persons to the system and supports different functionality. For example, one person working at one machine or at multiple machines or groups of persons working at a machine, and all that can happen with breaks and so on. So our system automatically then calculates the main power per order, per piece. So we have the real-time workload needed during production. Production data management of this module I told to reduce paper needed in manufacturing, because a lot of companies still work like this. They have to produce on a workplace, they have to produce something. So the first thing, if they have a new material, so we have to produce material number 1, 2, 3. They have a folder, a manual folder with paper inside. They get a folder and there's the description how to produce with graphics and so on. So we want to avoid this paper because there's a paper lost under the table, a wrong paper is put in. So we want to have the customers to have it in electronic form. So we are capable to store different objects, any objects. For that you have a viewer to store the objects in our system and to offer viewers so the worker directly can open those objects. Whereas the management of the objects, there are 3 variants. Could be the version, if there are separate versions, changes are done, we can manage that in our database. So we can manage to have version 1 of this document, 2, 3 and so on, with identification, dates when changed and what is changed and so on. Within our system, that's variant 1. The number 2 is, this could be done in external systems. For example, SAP is capable to manage such versions of documents too. So the documents are in SAP and this is possible to download and upload the newest versions of these documents. So variant 2 is sending the newest version of the document as an object to Forcam. And the third variant is avoiding to sending objects, is simply exchanging links. So the version management is external. We are only getting a link, a web link, and Forcam system only uses this link to show the object. What objects this could be? So the most sophisticated object is on machines, might be drilling machines, is the NC program. These are really programs. So we have a DNC inside, so we could manage different NC programs with differences and directly send and receive NC programs from and to the machine. So we have a dynamic NC interface called DNC. Planning utility, detailed planning. What's behind? So detailed planning means to find the correct sequence, the best sequence of orders on the machine. So every line is a machine and these are the orders to be run on the machines. And this utility helps to find the best sequence. So we can define rules and we have an inbuilt simulation. So the planner can click on simulation and then within seconds we calculate the ideal sequence of the orders, and then he has a graphical interface and he may manually drag and drop this information. So maybe he has the experience or sees the real-time information. This machine has a stoppage, so there is a problem, so he might drag and drop the order from this machine to another. And he directly might see what does this mean to the other orders. They are shifted. And this is a very important tool for some planners. It's an easy tool, but it helps. A lot of planners are doing that right now in Excel. And Excel is very hard. It's difficult. You have to move manually all the things. we do it automatically. And on the other hand, on enterprise resource level planning, SAP does it on a very rough day. SAP can only plan daily, so during the night. So they plan to produce these parts within this month, that's okay, but not within at what day in the week or at which hour and so on. So you need a more detailed system, and that's exactly this. What you can see here is the capacity. So how much persons do I need to produce? If you predefine how much persons you need to run a machine, you here can see how much persons do I need in a shift. That's exactly what the MSR guy told. So he tries to use 5 days a week, maybe 2 persons at this machine, and then skipping 1 day, and this saves money. So you can optimize the resources here too. So once again, the principle of Forcam is information from ERP, ergonomical interface, planned performance, the target, information from machines, information from the workers, seeing the actual throughput, detecting the actual performance, and optimizing, improving manufacturing. That's it. So once again, the summary, last slide. What are the key facts of Forcam? These are, from my point of view, a seamless, best SAP integration on the market. As far as I know, Forcam has the best SAP integration on the market. Second is this technology, this real-time performance. Not offline next day, but real-time mass data, analysis and optimization is the second key benefit of Forcam. And the third is the experience in the shop floor world to the data acquisition, to connect to different CNC controls and so on. These are the three key facts for Forcam. Started right now is a so-called VMware. It's a software that simulates servers. So what I'm simulating here is on my notebook, I simulate the application server of a customer, and the complete system is installed on these notebooks. So you see the requirements for a big server aren't that big because it runs on my notebook. And if we have a closer look, what is running, so we see there are different web servers running as services. That's important for the maintenance. They want to run all the application as services, so easily to restart. So if there's a failure, we easily can restart an application on the server. You see there are more than one web server, a runtime server and an application server. The reason is that some tasks have more priority than the others. For example, the acquisition of data has more priority than the user generating a report over the last 5 years. So this is the reason why we have multiple web servers. In parallel, most customers want us to have the data stored not within our system but in a commercial database. And typical, the market is nearly half to half. One prefer Oracle database and the others prefer Microsoft SQL Server database. So with the application we support to have a third-party professional database to store the data in. Reason behind this that the administrators of the customer want to hold all the data for backup and so on a special database. Okay, all this is running at this machine, my notebook. And now it's getting a little bit complicated. So I open 3 windows. The first window you see here is simply a simulator, because I don't have a machine right here to connect. So I simply have a simulator to simulate a machine, and you will see there are 3 signals: spindle, cycle time, feeder, and I program the logic. So only if all 3 signals are 1, this means production. And I have a small counter, so I can simulate production of pieces. So this is only my simulator of the machine I will use later on. And now let's open another 2 windows. The first window I want to introduce you is the worker client. You remember, worker client means ergonomic interface close to the machine, the terminals where the worker access. So I start a worker client, and you see typically this is run without those Windows icons, so that it started on a machine and the worker isn't capable to jump out of the application. So you see different menus, the big buttons, they might be directly used with touch screen. So I have a touch screen, I directly can touch to the screen and press the buttons, big buttons to use. This is worker style, a lot of graphics and symbols, so it's easy to understand. That's a HMI that the workers like. For sure, the look and feel may be different from workplace to workplace. Now we have one system. The look and feel here is 5 buttons and maybe a detailed view like this. On the other hand, you might on the same system start a worker client for another machine. Maybe there are other functions configured because this is another workplace, and might be the presentation of this window is different, so you may adapt the workers client to the needs of every special workplace the customer has. Maybe manual workplace differ from machining workplaces. So close again. I don't want to make it too easier to understand for you. So this is the worker client. For sure you can switch the language. You can change language. Yes, Chinese, sure, but I'm sorry, I don't have it in my demo right now, because if I would switch to Chinese, I wouldn't be able to.
You can also switch to Korean now.
I can switch to Czech or to Français, but yeah, so let's switch to Français. To France, so yeah, you know, sous-menu, option, back to Deutsch, or better, let's switch to English. So English US maybe is the best, then we can do it right now. But sure, the same is possible for all languages. It's multi-language, so the languages are maintained within the database. So it should be easy. We can give you access we can export the database, for example, in an Excel sheet, and we can give you the Excel sheet, so you might translate from English to Korean or to Chinese, the same. Okay, worker client. Easy to use, big buttons, and so on. Now let's switch the role. If I'm a foreman, if I'm the manager of the manufacturing, I don't want to use such an interface. I don't want to install anything on my PC. Maybe I want to use it at home. So the only thing I want to use is an Internet Explorer, a browser, a web browser. So the only thing I need is a link to my web server, and for sure the IT should prepare the firewall that I'm allowed to use this port. It's a so-called port 8080, this is the access, the number that the IT has to release for me to use from outside and nothing more. And then you could log on to the system. I now check in as a user named Visu. Here you can choose the language too, so different languages. I can log on to the system, and depending to my user, I get roles, I get access, I get views to my system. So you might see there are some visualization and the reporting, but not more. If I log on to the same system, but with an administrator's account, so I have a lot more things I can use. So depending on your name and role in the company, you get other menu, you get other rights there. All the administration within the system could be done here in master data. You can configure, for example, those users and roles. Let's jump into this. So here you define users and roles. So you might define roles, supervisor, administrator, planner, or you might create a new role named demo. So you can define, I want to define a new role named demo, and demo is allowed, what he's allowed nothing to use, then shift all to right, or all, or specified functionality. So I can go to reporting, and I can then tell, okay, he's allowed to use this report and this report and this report, nothing more. So this configures the access rights of the user. This is a role definition. And now I go to users and can define users. I can create a new user, giving a name, it's user XYZ, and I can define this user has a special role, so I can add a role. This user might be a supervisor, has supervisor role, but only in a special organization unit, means only in his group at the press lines he is the supervisor, and he has an additional role. He might be viewer only, so he might be visualization for maybe the whole plant in Friedrichshafen, Germany. So you can add a user, you can give him roles. You can define at these 3 machines he has the total access. For the other of the company he has only visualization, and outside of this he has no rights. So this easyfies defining of users. And that's only a sample, so a lot of things you can define here. You see a lot of administration you can do directly via this web interface. Okay, short introduction of the administrator's role. But now let's simulate what happens on a standard day. So, and now I change my roles. So on the one side I will be the manager responsible for the plant, and I want to see my plant, for example. This is my plant, and this is my most important machine, and I see, okay, there's free capacity. That means nothing is running, so nobody is at the workplace right now. Let's say I'm in the morning, 7 o'clock, I come to the company and I feel, oh, nobody's working, machine is blinking. Okay, and now I switch the role, now I'm the worker. So let's assume I'm the worker, I go to my working place, and now I come, oh sorry, mistake, once again. So I'm the worker, I go to my working place and I do coming. So I select not going but coming, and maybe we have a card reader at that terminal, so I simply hold my card there and then automatically the user is registered. Maybe not, then I type in my personal ID. As you might see, we prepared especially for shop floor, because maybe in shop floor there's no keyboard, so we have an onboard keyboard for characters and for numbers and so on. So let's log on to the system. Now my ID is number 1. The system automatically reminds on which machines I was working the day before. So the system makes a suggestion at the same 3 machines you worked the last day. So I clock on to these machines. Now the Forcam system knows, okay, the worker now is at his workplace at these 3 machines. From now, the time is measured. Next step, I have a look to my 3 machines. So this is a sample. Could be 1 machine, could be multiple machines. It's a pure logical combination. You could place terminals wherever you want. You could use wireless, you could use multiple terminals. You could freely define which terminal is linked to which workplace. So I'm the worker, I'm responsible for those 3 machines. So I go to my first machine, this Makino, and on the right side I see the list of orders I have to do in the next hours, in the next days. So typically these are from top down. This is my orders I have to do from top to down. But sure, if I'm administrator, I can define a sort order by time, by name, by numbers, whatever. Typically, the sequence is predefined by a scheduling, by a detailed scheduler, maybe the Forcam planning board. So I select, I can have a view, I can see the information from SAP, and then I will start an order. Now my material is prepared. I will have both windows open. In this window I'm the manager, and in this window I'm the worker. So I'm the worker and I start setting up my machine. So you see, simple click, setup is started. What happens? First of all, the manager sees, oh, now it's blue, it's not longer white, and he can read, oh, setup is started. When is it started? What's the duration of setup? So the manager now sees, okay, something happens in my workplace. If he wants to go into detail, he can do that. So he might go into detail, asking the system who in person, what persons are at the workplace. Maybe what order is on the workplace, how much pieces to produce, and so on.
Sorry.
Yeah.
How about what's the meaning exactly for the setup here?
Setup is preparing the tools, mounting the tools to the machine.
So from the machine side.
From the machine side, means setup from machine side. Yeah.
Ah, okay.
Yeah.
It is ready to run. It's ready to be running.
Making ready to run.
Yeah, making ready to run. Yeah.
Yeah, mounting some tools and so on,
Yeah.
preparing to run.
Okay.
And very important, we give direct feedback to the worker. As I told before, the worker should know what to do. So, for example, I told this screen may be customer specific. This is simply a HTML view the customer can define. But it's a good idea to have, for example, such a bar telling the worker the planned time for this preparation of the machine with a new order is 35 minutes are planned. You already spent 16 minutes, so half of the time already is gone. So I now have the white is the time I have to plan. If I have this information and I'm the worker, so I now would speed up, because I know the manager knows only so much time left. So this is what I meant before, feedback for the worker. So giving him feedback, planned is 35, half of the time is spent, go ahead, speed up. So now let's assume I mounted the machine and now I'm switching the machine on. So I start the order. Maybe this information could be automatically from the machine. In many cases, Gesundheit.
Thank you.
In many cases, that isn't possible from the machine. Then the user has to press a simple button. Process, start the operation. You see, this is changing. Now here are the pieces already produced. Yesterday I produced 47 good parts and 10 scrap parts. So I have to produce 100, so 43 parts I should produce right now today. So direct feedback to me. The machine is in stoppage, means the machine isn't running in the moment, red. So the manager sees, okay, machine, now there's an order started, but it's in stoppage, so lights on. So I work on that, switch on the machine, and now let's simulate. This is my simulator. So let's simulate the machine is running. Okay, so machine is running, I get a feedback, green, machine is in production, green, wonderful. He's working. So machine is producing parts. I simulate some parts, maybe 5, 6, 7 parts. Now you can select, should the parts directly be booked to the order, or is it a manual thing to do booking? So here you might see 6 parts is the info from the machine that the machine produced 6 parts, and maybe I have to check that. So the worker goes within this screen and has 6 parts, and then it's a definition with the customer. Is the worker allowed to change this 6 to 5 because maybe the machine is wrong or not? And what's very often is, now the machine produced 6 parts, that's ideal. So here I have the 6 parts and I check and I see, okay, 2 of them are scrap, they are not good parts. So maybe as the worker, I type in 2 of them are scrap. Maybe there's some rework too or whatever. So say report. Now the system automatically can ask me, what's the reason for the scrap? Give me a reason why you produced scrap. And the system automatically sees the quantity, 2. Okay, maybe only 1 has a reason. The reason for scrap was, and now you see here, a group and the reason. So maybe it's a problem of the machining. Maybe the machine was too cold. Report and add. So 1 piece scrap reason was machine was too cold. Still I can't close the mask because there's another. So the system counts, or another reason. Maybe this is a problem with evenness. Report, add, and now it's enabled. Now I can leave this mask and book the parts. So the system guides the worker that he can't make errors. He can't leave this mask without giving 2 reasons if he defined it's 2 scrap. Now the booking, you might see, the manager might see, yes, now 51 pieces are good. Okay, so what's now if a stoppage occurs? Maybe I simulate a stoppage right now. Maybe the machine is giving me the info about the reason for the stoppage. Error number 102, material problem. Might be I get this info out of the machine, then it's wonderful. The machine defines what's the reason for the stoppage. In many cases, so let's go ahead. In many cases, the machine doesn't have the information about the reason behind. So let's simulate two stoppages. So I have another stoppage, but I don't have an information about the reason of the stoppage. So this is error code 999, undefined stoppage. So it's simply, I have the information the machine stopped but I don't know the reason. What I now have to do as a worker, what do I want the worker to do? First of all, he should make the machine running again, sure. So I'm working on the machine, getting the machine running again, green. Then maybe I'm checking if all runs well and so on. And after 10 minutes, now the machine is working, problem solved. Then I want the worker to go to his terminal to try to select the status overview, and then he can see exactly times. Here are the seconds of the stoppage. I exactly know the stoppages. I can see the history. There I started with my at the day. This is exactly the start time of the day, 6 and so on. Then there was a stoppage, I got into production, there was a material problem and so on, and I had 2 undefined stoppages. You understand?
Yeah.
Okay, and now what I want is for sure, I switch to the manager. The manager wants to know what's the reason for the stoppage. Undefined is, I can't optimize undefined, so what I want the worker to do is give in a reason. And there might be some filter to the undefined stoppages and give me a reason. And maybe these 2 stoppages had a reason, and now it's the same structure. Select a group, select a reason. Now maybe it was 2 was because of breakdown of I had a quality problem. I had a quality problem at my machine, so still 1 is left. So this one wasn't a quality problem, but this was maybe organization because I had no operator, because somebody wasn't available. So no operator, no machine can detect things like this. So I want the worker to give in the information. So now the status now is coded to quality, quality and so on. And this enables all the reports we have seen before. So let's go to the manager right now. If the manager now can't not only have an online visualization of his machine, but he can use a lot of reports. So, for example, I can start, this is all the reports we have predefined in the system. Yeah, a lot of reports. We have an own editor in the report editor. He can predefine his own reports. Then, if I choose a report, for example, a cyclic runtime log of my workplace, so you see there are parameters. I can select, for example, a single machine, or I can choose the whole location, Germany or plant or department. The customer is up to define a structure of some levels as he wants, organizational levels. So let's select the machine. I can define a time span and so on, and now I as a manager see exactly the timeline from today. At this machine I had no operator, then I had a material problem, and then I had 2 quality problems. For example, now I have the values. I can have summaries, so in total in this shift I had 7 hours production and 15 minutes free capacity and so on. So I see the percentages. But I now have to define which machine and time span and so on. I don't want to do this every time. So I can define a favorite. So store as a favorite, giving in a name. So next time I want to reuse such a report, they are here with the stars. So I can select my report and you see all the settings are stored, so predefined. So these are favorites. And you simply have to click on open that report. And reports may be numeric values like this with graphics. So these are the typical graphics that the customers want to analyze, maybe to compare machines. This is a report, or to have this diagram we had before with the plant value against the true value, or whatever. So the OEE, so you can see OEE, a weekly OEE, for example, in this case week by week, or you can choose, no, I want to have a daily OEE, calculate, now I have the OEE per day for a month or whatever. So you interactively can work with this data. So a report at Forcam site isn't statically. And if you want, you can define, send me exactly this report as a PDF, so I can open the PDF directly with header and footer, and I can define, send me exactly this PDF per email. So start a mail server and send me daily or whatever. This is what I call alarming, alerting. And now let's work interactively with the data. For example, a hit list. I select a machine or a group of machines, so I'm telling the system, give me the machine errors that happened from week 10 to week 12 within these 2 weeks. What were the states that the machine had? And now let's filter to only errors, means no production, no setup, no breaks or free capacity, and so on, no planned maintenance. So let's focus on stoppages. So once again, stoppages. So I see the frequency, how often that happened, and I see the duration. Maybe I choose that I only want to be analyzed stoppages that happened at least 10 times and the duration was at least 5 minutes. These are my top 10 errors. And now make a graphics, a bar graph, to show me the biggest problem. And then I can see the blue line is the frequency, how often, and the bar graph is the duration. And I can identify there's one major problem at this machine within these 3 weeks that occurred most often, and the duration is the longest. That's exactly this problem. All the others are minor problems. So I can focus on exactly this one and go into detail. So let's see. This machine problem, which material number it was. So I can track the orders, which order number were the stoppages, or go here, at which material number is there a combination with material number or whatever. So I can dynamically work with this data from the database. That's how I interactively can work with the system to find a problem. These are reports, and there are a lot of reports like electronic shift book. So we can have a shift book not in papers but in electronic form to have an overview about the last shifts, the shifts of yesterday with details and so on. A lot of information about the system. And if I combine now web visualization, might look like online state with possibility to directly go into reports. So you can click from visualization directly into reports per hyperlink. You can have visualization in easy way, rectangles. You may define like this. Or in a more graphical manner to show a line like this. It's up to you. You have your own editor. The customer may define how to look like. And if you mix both together, the reports and the visualization, these are the cockpits. So let's open a cockpit. This is a typical cockpit mixing. This is one that's used by Audi. They want each machine to have such a cockpit, seeing the day, the planned value, the actual data. They want to see the target quantity was 9,009 pieces at this line. They made 8,400 and so on. The OEE was 80%, availability was only 46%. So they wanted to see the OEE for the days of the week. This means Monday, Tuesday, Wednesday, and so on. And they wanted to see the top 10 problems. The top 10 problems by duration and by frequency. So this is a cockpit, only wants it like this, at this line. Maybe another customer, Jenbacher in Austria, they prefer it like this. They like this instruments, more the instrument view. Depends to the customer. And still, these reports can be opened with parameters. So the cockpits can have parameters too, so I may select another machine. And if you now see, this only is a web link, so I can directly call this web link from outside in any portal at a big screen on top of the hall. And if you now think, the machine selected may switch every 10 seconds or every minute, and that's exactly what we are doing. So putting a big screen somewhere in the manufacturing, having such a cockpit and scrolling minute by minute through the information. Putting that into the coffee break corner, so everybody could see, oh, it's red, the coffee, I go to work. That's what we are doing here. Okay, so let's see the other modules. That are the core modules, those green ones. For sure you have an order management where you can go in and select data like show me all orders that are already in, at least in setup, but not finished right now, that are planned from calendar controls and so on. You can use show me all orders that are in work right now with coloring, with detailed information about planned times, planned quantity, actual quantity, and so on. You can see all the information. You might use this planning utility I showed to you, means the best sequence of orders. So this planning board for the planners, if they want this module, I can give you a short overview how this is used. So let's open a schedule board, and now I can do a simulation. So I tell the system simulate. So I first have my capacities, so I select my workplace. For example, it's simple per drag and drop. I can drag and drop workplaces or resources to my planning board. You see, in the moment nothing was planned for today. I can start a simulation. The system now checks all the orders and gives me feedback. Material is missing to work for these orders. So this might be a list to be checked. Now I have to prepare the material so the machine can run. And now I can compare what the system plans to do. So I can drag and drop here the capacities and can add persons for setup, for production, and so on. And now we have to go to the actual date. So that's how I can work, and I see the orders. Let's place orders here. So this is how the planners work, and they optimize by drag and drop. They optimize the best, they find the best sequence of orders with this tool. They can define shifts, shift models, they can do some experiments. What happens if I skip a shift? timeline is moved backwards, and so on. They work interactively on the best, finding the best plane for manufacturing. That's planning module. Then production tools, and the result, maybe the result of the planning may be written back to SAP to have a better understanding about the sequence, and the result typically is the sort order here. So if I change my plane, so the sort order here will change. Now production tools, you remember those paperless objects, using paperless objects, less paper in manufacturing, so we have here the management of those objects. So I can define various tree structures to structure my documents I have, and then within this you might see here there are containers including objects, and you can define the system to only show the maximum version, or you can tell the system show me a version history, so I can see this NC program, for example, has a version 3, a version 2 and a version 1. So there are different versions of the same object, and if you want to change, you have to check out under the control of the system and check in again, and then you can compare versions. So I can compare version 3 to version 1, so show me the difference of the two programs. So this exactly were the changes. So I had a version 3 and a version 1, and the colored things are differences to the program. So I can exactly identify what did the programmer change from version 1 to 2 to 3. So that's what we think is transparency. These are all identical. Yeah, here is a difference again. So here they changed some lines. Okay? So this is the management of the documents. Ensures a versioning and controlled changes. For the user, this is much more easier. The user is in his worker client, selects his order, and then goes to DNC and now sees all the objects. He might see that some of the objects are green and C programs are released, so he might directly send or receive from and to the machine. Red are blocked, so he can't send to the machine. And this not only works for NC programs, for sure, this is important, but works for all other objects too, whenever you have a viewer. So maybe these are graphics like this. So if you have a CAD viewer included, integrated, so I can directly open my CAD graphics, or my tool description, or a measurement list. And this exactly is the interaction with QDAS. So for example, we can have some checking instruction from QDAS showing here to the worker, then doing some measurements, and at the end transferring the results of the measurements back to QDAS for statistical analysis. Now I am the NC programmer, so the machine worker did a receive from the machine, so has an optimized program. Now I switch my role, and I am the NC program. The NC programmer goes into his environment and opens a list, so he can have a list to show which programs are changed. So he has a daily list, which programs did the worker change, and then he go select one and go into show me the differences, and if the programmer says yes, this was a good change, so he can release again to use it. If not, if the NC programmer says, oh, the worker, this wasn't good, so he can deny that. So we can read back and check the versions, the changes. And we can even more, so OD requested that this cycle should be done automatically. So they wanted to automatically detect changes done on the machine in the background, so the worker doesn't see anything in the background. So Siemens told Audi, this isn't possible. Yeah, and we only did it. So we did it at Audi. We directly in the background saved the program, matching, identifying the changes and logging that changes. Because for Audi it's very important that somebody does changes to the NC program, then something happens, there's a scrap out of the thing, and then they ask the worker, did you change something? No, didn't change anything. But then it's documented. You can go into the system and tell him, but yes, you changed, and you changed exactly this line, and you had the machine running with more speed, and that might be the reason for the scrap. Okay. This is production tools. Hopefully you now have an impression, and maybe I show you something again. This was the point where I told you there are three possibilities. You can do the management within our system, version history, that's what I showed before. Second possibility is that this management is outside, done by a PDM program. For example, SAP, then we simply get the objects and we can show the objects for the worker. So the worker has the same objects, but the management here within Forcam isn't used. This is an external tool. And the third possibility we have is external tool only giving us links to the documents, and that's what I want to show you right now. So you can have only links. So we got nothing, then a web link, and then we have the pictures or sheets or whatever that are managed outside, and we have access to a web server, port 80 or something, and get the documents from outside. All three possibilities are supported. Mistyping, that happens, so you should be able to change number of pieces or a problem code or something like that. For that we have a correction module. And if you do changes, for example, you change the coding, so let's see, 2007. So the latest one was this quality problem, and I now have the possibility to change. It wasn't a quality problem, but it was something else. And this I can only do within the shift. Within the shift might be the worker is allowed to change. But for the past day or last week, the worker for sure isn't allowed to change, because then all reports will change. So maybe the manager is allowed to do this. And if I change right now here, I change, so all the reports are recalculated. All the weekly, monthly reports are recalculated again. Let's have a look on this traceability. I explained traceability, serial number and additional information. Example, I go into the system and I scan data from the last years. Please show me my data, and then I have a list of all my products, serial number. And you might see there's one product that is not okay and the others should be okay. So I can select any part, and now I have the detailed information. This part with ID number 100019 with data matrix code and all additional information was manufactured 2012 at the 27th of September. And it is a turbo charger. So this turbo was assembled with the following components. It had a compressor wheel, it had a turbine housing, a turbine shaft, and I can go into more detail. So this compressor wheel, the values, the turbine housing, which are the values, and so on. So I can go through my components in different component levels, first and second packing level, so I can go through my data. I can see the components that are assembled to my final product, and I can see the results. So if I go to my turbolator back again, so I can see it was okay, but I can see the curve data or torques too, so I can zoom in and can have a look. These are the measured values. Show me the graphics for exactly that turbolator. So this was the measurement, and as we see there with the red line, maybe exactly this is outside the spec. So might be in the first run this was okay, but after 2 weeks we had a detailed view and measured, okay, it was not okay. So give me the raw data, and then I can have a look. With this serial number I can have the information. Typically we do exactly this. Maybe the summarized data about the product, the maximum torque, the minimum torque, and so on. This information is ideal to send via the interface to CUDAs. I think it's not a good idea to send CUDAs all the detailed values. OD wanted us to do, but was an overload. Because your database is prepared to do statistical analysis, not this detailed in milliseconds. Yeah. So this is exactly the interaction with CUDAs. So we are measuring, have very detailed information, and the summarized information automatically is sent to CUDAs for later on statistical things. You are the expert.
Just number, etc. Yeah.
Exactly, some summarized information, or
but we don't need the detailed information of the process data or some production data.
Yeah. Exactly. And this is the interface we have. So we have the detailed info, and then we sit together with CUDAs and the customer, and we are talking about which are the information you need for your, and then we might define some information and we transfer via the interface.
Yes.
Okay, this is tracing. Maybe in some cases recite management might be interesting. I'm not sure if I have data inside this module. So this is a type of setup values. For example, for ovens, we can redefine recipes. So setup values for ovens. So here to define this oven should 12 minutes heat apart at 200 Celsius, then should cool down for 30 minutes at 80 and then heating again, so define ramps and so on. We can define those recipes and then send to the machine corresponding to a material number or any other ID. This is recipe management. Yeah, for sure we have the master data we've seen before, a lot of data like for example the operating states. You've seen the states and the colors. So this is all could be changed by the administrator. So defining, is it a red or orange or whatever, which color, and defining the workplace, the machine parameters and so on. This is all done via this. Important for the reports is to define shifts. So this is very important to have a reliable shift management. There it's similar to SAP. You can predefine shifts, maybe 2 shift or 3 shift, and then here you can define Monday I work in 3 shifts, in 2 shifts, whatever, on these machines. So you can exactly define how your days are split to shifts. This is based for any reports, daily reports and weekly reports. So it's easy to define. You define your different shift models, and you simply define this shift model should run from date to date. You can define your shifts. Okay. Last is documentation. There's an online documentation. as PDFs. You can include any PDFs for your own, and for sure within every screen you might have online visualization. So you can select online visualization and getting help with pressing F1. You can have online help there. So you have online help that you may, as I told, this is in the database, so you can for your own edit this online help if necessary. Most of the customers want the online help, but never look in. They want the system as easy to use, so they never look in there. Okay. So there are some special functions to define claim reject act tickets, for example. For sure, as I told before, the worker should see the visualization or Gantt diagrams and so on. All the reports we have seen in the Office client could run in the worker client too. Web links, simple web links, because it's a web solution. Or sometimes it's a good idea to include any other web content, for example, the menu of the food. You can include here, or whatever, the newest documentation of the customer. Sometimes it's the easy things that makes the benefit, that makes the workers happy. So why not include information about the sports program of the company or whatever. So you could link via web the information. And there are some additional special functions like barcode reprinting, because very often the customers use barcodes to scan on and to jump directly in the system. For example, they scan a paper of the material, they scan, there's the order number, so the system directly jumps to the corresponding order number. And there are functions like reprint barcodes, so we are capable to print out these labels, these material labels. That's important for logistics, material handling, so we can print out those labels in different layouts with barcode on that and so on. There are some special functions that are included. So, this is the software. I think this is a good moment to make another break, maybe, or you have already questions right now. I can show you more. I could show you another 3 hours details of the system. I think it should be, hopefully giving you a feedback, it should be a lot of functions you have seen, and I think now you understand that it's not only a small software or a visualization. No, it's a lot more. It's a complex software tool, focused, and via this tool it's possible, if you have a continuous improvement process running, via this tool you can fulfill this target plus 20%, plus 10% or whatever.
Yeah, especially for assembly process.
Yeah, especially for assembly there's a lot of handwork. So I go to assembly. So it could be that you do the stop and start manually. So the person is pressing I'm producing, or there's a start of an interrupt, simply select interrupt, organizational, material missing, okay. So they can do it manually, so they can make their interrupts manually. Mm-hmm. So the timeline isn't done automatically by machine, but they do it simply pressing 2 or 3 buttons. That's how we often do such workplaces. So only a few buttons on the right side where there's, say, production, or now I have a problem, and then to select which problem. Or the top 5 problems, even only 6 buttons. The first green I work the next 5, the top 5 problems I have. No material, no persons, material defect, something like this. So we can realize manual workplaces through this very easily. We have the type of workplace in different steps. So we have workplaces where we have machines automatically connected without any person at the machine. Typically those fully automated lines at the car manufacturers. No person in the hall, so 100 machines running for their own with robots, no person. On the other hand, you have seen a little bit a difference is a machine. The interrupt comes from the machine, but the person is somewhere typing in a terminal a reason. That's the mix mode I focused on in the live demo. We have other station where only a person sitting at a table, mounting some pieces, typical in assembly area. So what we do is placing a terminal somewhere here with the big buttons, productive, problem number 1, 2, 3. So they are simply working with the screens. They have 5 buttons here, running problem number 1, 2, 3, 4, not more. And then they clock onto the system. In the morning they come, clock onto the system. They are telling the system, and that maybe they manually enter the number of pieces. After an hour or so, 10 pieces are done, so they enter the number of pieces pure manually. Then we have the workload of the persons, and the most critical, the most complex are the mixed lines. There are some lines, they do like this. So there are some machines, machine 1, machine 2, then there's a manual workplace 1, and the piece flow is like this. And maybe there are some persons within the line. So it's a mixture of machines and persons. So these are very difficult to blend because might be the output is 100 pieces a shift. And now the critical question is, if I add another person, how much does this help? Is it maybe 150? Yes, a third person may have 150, but if I add a 4th person, doesn't help because the machine now is the bottleneck.
Yes.
So this doesn't make sense, but if 2 persons are missing, now the persons are the bottleneck. And that exactly is what we are doing and calculating exactly. For example, in a French company at SEW, they have these complex lines in combination with machines and persons, and they are analyzing with our software how to manage the best efficiency, making buffers in between and so on, trying to optimize these lines. But for all the software is suitable. Many often we have different areas at one customer. We have different areas. So one area is the production of parts, drilling, milling, and so on. There we find a lot of machines and less persons. And typically in assembly we find these mixed things. This is typical for drilling, milling, grinding. This is typical for assembly, and this maybe is typical for example, for packaging, sending out, palletizing and so on. So we have the same system, one system of Forcam, simply configured in 3 ways. This configured without a worker client directly connected to the machine. This the mix mode, machine interacting with terminals, and this only terminals, no machine interaction. And for all 3 we calculate the machine hours and the person's hours. Okay, so another thing I want to explain is there are a lot of reports not fitting for all industries. So this report I had many often. It makes definitely sense for mass production.
Yeah.
A lot of parts during a time.
Mhm.
Such a thing doesn't make sense for aerospace industry, where you during 3 days you are producing one part, very sophisticated. So totally other reports make sense for our MTU aerospaces. So they don't use these reports, they use other reports for sure. They have the same requirements, they have the same requirement for improving the process. And they can do exactly the same, simply using other reports, other information. Maybe for them it's less the cycle time, it's more the time it takes through the machines. The time to delivery for them is more the interesting thing.
Correct.
Not the cycle time of each product step. Yeah. But we have them both, in the break we talked about semiconductors. So semiconductor is a different world, so we are trying to get more into semiconductor customers because they have the same needs. They have other interfaces, yeah, they have standardized the interfaces, that's the good thing. And I'm sure our product will fit ideally to semiconductors too, but we don't have the connections to semiconductor companies right now, but I'm sure it's possible to use it very easily. The special wording of the semiconductor world, they are maybe not talking about orders and materials, they have other namings.
The terminology.
They're using a technology language, so we should have somebody who is familiar with this wording they are using, translating, setup and those things. So maybe it's not named interrupt in semiconductor world or totally different. So we can rename this all if we have somebody who is familiar with the wording and can sell to the customer.
You mean a professional word for certain industry?
Yeah. Yeah. Every industry has a special wording.
Yes.
And for sure our translation is capable to put in any word, but you should know. And you should be capable to talk with the customer, because the customer likes to have a salesman that has experience.
Correct.
So he wants to feel the experience. Yes, he understands. Yes, he knows my requirements. Yes, I already have another project in that area. Yeah, that makes it, in the moment it's a little bit hard, but we are struggling to have our first project in semiconductor world too, or in others too. And it was the same with food. I never thought, if I had the first requirement, food industry, so I thought, oh, food industry, maybe they like totally different things. And after the project, I was totally astonished. They exactly use the standard. As it is, no difference.
Yeah, I think the philosophy of the manufacturing is quite similar.
Yeah, and even the wording in this case, they talk about killing pigs, but they are not. They are talking about production. We are producing meat, and so on. They have the wording like manufacturing any other parts. Yes. So, what else can I?
But I think at the beginning it can be used, because I think for such product mostly will be start from a foreign company or joint venture company in China. So at the beginning for joint venture company normally it can be used.
I think it's more depend on, it depends on customer has enough budget for this.
You have some money, otherwise
because
for
many nation-owned company, the government support them. They have enough money, so it's not a problem. But anyway, the philosophy to manufacture product with high quality, with the time saving product. This should be, I think, compared to the foreign companies,
Yeah.
the philosophy is a little bit different. Because now the local guys is learning from the abroad.
But still everybody likes to save money.
Yes,
Right.
that's the point.
So if you can calculate the return of investment, like you need to invest this in Forcam system, but
Right.
you can save millions of dollars or RMB
Yeah.
by using it,
Yeah.
it's an easy thing. So
Yeah.
that's
Right.
Yeah. If you calculate how much is your invest for such a system, costs $6,000. So, and then you calculate, maybe it's not the 20%, so they are not sure 20%, okay, 10%. So simply calculate this 5%. So take the machinery cost, the person's cost, think about how much money is 5% for your company, and then you calculate, okay, I have a very fast return of investment.
Yes.
Maybe it's a good idea to talk about pricing. And first of all, I want to fix that I don't like to make prices for your market. So
No.
you should address Henry. Henry is responsible
Yeah.
for sales.
Yeah.
So he does the pricing for this market because he knows
Right.
all the local things. So I can only explain what are we doing in Germany or in Europe.
Yeah.
In Europe, first of all, if a customer, and most customers don't like to directly start with a project, we sell them those workshops. We are selling them a workshop one day at the customer with 2 persons from Forcam side, and we are telling him, okay, this is one day, 2 persons at your location, half a day preparation and half a day documentation of the system, so you have to pay 3 days workload. So we offer a one-day workshop, management workshop for 3-day payment. And we do the same. This fits if the customer has a focus on these green modules, the standard modules. If he is interested in doing planning or data management, so this is more sophisticated. So we recommend to do a 2-day on-site with 2 persons, and preparation and documentation means we like a payment of 5 days from the customer. This is how we do in Germany. And we do a calculation of the system. So let's go to this module. Okay, so means if we have a customer who's focused on those green modules, so we typically tell him you pay, for example, 3,000 3 days, and we are one day at your location and you get a perfect documentation. If you are interested in one of this or maybe 2 of this, so you should have at least 2 days at your location to see the workflow and so on, because this means analyzing the workflow, this means talking about planning strategy and so on, more sophisticated. Okay, if the customer wants an estimate, a budget quotation, so what does it cost? So the first part is licenses. So now it depends on the modules the customer wants. So we ask him which modules do you want to use? And there are some modules he has to pay once. So there's a price once to pay per plant, for example for the SAP adapter. So there are some licenses per plant, for example the SAP adapter, and most of the licenses per module are costs per machine. So the other is per machine, or better per workplace, because could be manual workplaces, not only machines, but in many cases this is the number of machines. So we can give him a license price if the customer tells us, yes, I want SAP adapter, all the data, the visualization is one block, the visualization and machine data. So it's once per plant the cost for an SAP adapter, and I need to know the number of machines or workplaces multiplied with the modules we have here. This is the licenses to pay once, like costs one time. Yeah? So interesting for us is how many plants has the customer. It's one plant with about 20 workplaces or 50 or whatever. Then we can calculate the license costs. What does it cost for the license? Then we have annually costs for maintenance. Year by year, it's 80% of licenses. Means if this is 100,000 RMB, so this is 18,000 RMB per year to be paid for maintenance. Maintenance includes not only service hotline, but includes license free updates. That means if we have a new version with additional functionality, the customer gets that for free. Because we want to avoid, and if you think about that, that is 6 years. So if we want to avoid that the customer 6 years uses the old version, because then he has a lot of bugs inside and not new functionality. So we want this 18% to ensure every year or every half year he can have the newest version from us for free. The license is free. The only thing he has to pay is the services for installing, yeah. But the license then is free if he pays those 80% of the license cost. The second, this is one licenses with maintenance, then there are services. This depends on which modules they use, what do they do for their own, what do they request, training and so on, training, installation, configuration, doing project management. This depends on the customer. So typically in many projects it's on the same price level than the licenses. So typically might be we have 50,000 for licenses, then typically the services may be in the same range. This means only paying the manpower, how much hours we are at the customer or working for the customers. And if necessary, maybe there were some additional hardware costs. For example, if he needs those I/O boxes, or he wants to have some PCs or sensors from your side or whatever, for sure this is hardware costs. And these are typically the points we fill in a budget quotation or in a final quotation. Typically we can give a budget quotation if we have the rough numbers, how much plants, how much machines, which modules do you want to use, then we can make a rough budget, and after such a workshop we can give a final quotation telling more. And with Henry, I may in the next days or weeks, I may prepare a price list, especially for your market. So I'll prepare a list, and then Henry will go through and make a standard price list. Standard is, yeah, it's not a total standard, but yeah, you can calculate a little bit. And pricing, you have to be careful, because we offer our system, the Forcam system, and showing in the workshop what's the functionality of the Forcam system. During the workshop on the other side, the customer shows his requirements.
Yeah.
If we are lucky, we have 100%, but typically, so we have an overlapping. So it might be, it's like this, then it's critical because we only have half of functionalities overlapping. Maybe the customer wants to have special things here. Semiconductor industry needs blah blah blah. So then we identify a difference, so we have to add some software development, a third-party software or whatever. In most cases we are around about 90 to 100%, but we have to check the requirements because in sometimes there's a misunderstanding what's a MES system. For example, some customers have the understanding that the automation itself, the control of the machines is a MES system, and that's not. So for us, the MES system is the system above the machines, not driving the line. And therefore you should have this workshop or have some discussions. What are your requirements? I show them what the system is capable to do, and after that we make a review, how good is the matching. And then we can have a pricing and give him the exact numbers. A little bit, the question was, does it make sense that I give you the demo software to directly show the system? The answer is no, not in the moment, because you should be well trained to use the software, otherwise it will be destroyed within a short time. But we have some integrated videos, so we have not only PowerPoint, but I have to open manually because I didn't maintain the links. So we have integrated videos, so in the PowerPoint you can click to the videos. A video is starting, showing the usage of the software. So showing how to do a report, to open some reports and so on. So it's not a real live demo, but it gives some interaction to you. Maybe this is a little bit support for the first step. And if we do some more training, so you are well trained, then it might be possible to directly deal with the software. Yeah, so let's come to the final test.
Yeah.
Fill out your sheets. Yeah. No, then let's close the session. I don't want to put too much information into your heads.
Yeah, but
So I would suggest let's stop right now. If you don't have more questions, so we stop. Think about it. If you have questions, addressed to Henry and Udo.
Yeah.
And yeah, we'll meet after some regeneration in the evening. I think we call. Okay?
Thank you very much.
Thank you.
Thank you.
Thank you.